Hello, everybody. Welcome to the LIUniverse. I'm Dr. Charles Liu, your host, and just like my high school friends that used to call me a particular nickname when we were playing Dungeons and Dragons, please call me Chuck. As always, we are very happy to welcome our co-host, Allen Liu. Hey, Allen, how's it going?
Hello, it's going pretty well.
Good. Have you investigated any artificial intelligence safety protocols lately?
Oof. Well, I recently downloaded a copy of Llama 3.370 billion onto my home laptop.
Whoa!
Um,
And for people who don't know exactly what that is, what is it?
yeah, it is Meta, the parent company of Facebook's, one of its latest AIs that's designed to be like small enough you can fit it on a laptop, but powerful in the same way things like ChatGPT or Claude are.
Ooh.
So I could get it to run on my computer, but only about like 2 words every 3 seconds. So it's like a
Oh.
really slow answering situation.
Uh,
But by keeping it all on my machine, I don't have to worry about Meta or whoever grabbing my data.
right. The
So
safety issue is there. That's very clever. We'll have to think about that. More on that at some future episode. But today we have very cool stuff to talk with, and our guest is Rob Sparks. Hi, Rob.
Hi, Charles. Hi, Alan. How are you
Hey.
doing today?
hey, doing good. Good to see you.
Yeah. Rob is at a cool institution called NOIRLab. Now, what the heck is a NOIRLab?
Well, it's an NSF Noir Lab, and it's nominally is what I call a tortured acronym.
Okay, so NSF is National Science Foundation. That much we know. But Noir, NOIRLAB, right? What is this tortured poets
Acronym.
acronym?
The National Optical Infrared Astronomy Research Lab. And it's a little
Okay.
tortured because there's some letters missing there, but it's really, I think, it's a very appropriate name because we run all the National Science Foundation funded ground-based nighttime optical and near-infrared astronomy for the United States. We don't
That's
Whoa.
awesome.
We don't do space. That's Space Telescope. We don't do solar radio. There's separate organizations for them, but ground-based optical and near infrared.
So
Wow.
everything up on Mauna Kea or
Well, not everything on Mauna Kea, just the National Science Foundation funded ones.
okay,
So
cool.
in Tucson here, we run Kitt Peak National Observatory, about 55
Yes.
miles southwest of Tucson. We run the
Yeah.
Gemini Observatory, the Gemini International Observatory, which has twin telescopes, one on Mauna Kea and one on Cerro Pachon in Chile. We run
Nice.
the Cerro Tololo Inter-American Observatory, which is kind of a southern counterpart to Kitt Peak in Chile near La Serena.
Yeah.
We will run the Vera C. Rubin Observatory when it comes online in early 2025. Hopefully, first light's coming up soon.
I'm
Oh,
excited for that one.
That's it. And we run the Community Science Data Center, which takes all the data and ties it together for all these telescopes and makes it available to astronomers around the world to use in their research. So
incredibly important part of astronomy now with all of that data running. Big data, we hear about that in our regular lives, but never mind. Astronomy, we basically invented big data, didn't we?
You and the
Yeah.
particle physicists.
Oh, yeah, those guys too.
one of my things I did many years ago was a fellowship at Fermi Lab in Illinois, but I was in the experimental astrophysics group working on the Sloan Sky Survey. So I had the
Wow.
best
Oh, nice.
particle and astronomy, particle physics and astronomy in one place.
Amazing. Yeah, no,
Sloan
that's
is an
terrific.
awesome resource, just like taking a survey of like the entire sky from all the directions and being able to like go through and see like, okay, I mean, I've used it to look at classifying specific galaxies.
That's right. And you did three-dimensional fly-throughs using virtual reality,
That
right?
was pretty awesome stuff.
Yeah, of Sloan data.
Yeah.
Yeah, so tremendous stories, great stuff to talk about, and we will get to them. But first, we must do, as always, the joyfully cool cosmic thing of the day.
Woohoo!
Yes. And this joyfully cool cosmic thing of today is actually coming right out of NOIRLab. There is a project out now, which is now available as of just a week or so before this recording is going on,
Mhm.
of something called 88 constellations. What is 88 constellations, you all may ask? Well, as it turns out, there are many constellations in the sky, and the constellations, of course, are just random locations in the sky where the stars happen to be as viewed from Earth, but they traced out things that our ancestors all around the world thought were kind of
Yeah.
cool. Swans, hunters, ducks, geese, any kind of strange things, microscopes, telescopes, etc., etc.
Yeah.
In any case, every field, every subculture in the world had their own constellations for a period of time. But a few decades ago, well, almost a century, I guess, by now ago, the International Astronomical Union agreed to establish a set of constellations, and they are the 88 constellations that officially map out all of the night sky for all professional astronomers to use, so that we have like a common mapping system, right?
Yeah.
The thing is, we astronomers, especially us research astronomers, aren't really good at constellations. We actually don't know. Oh, Rob's laughing because right? Working with us astronomers, that we'll have a sharp graduate student who can, do general relativity to beat the band, and you look up and say, "Hey, what's that star?" And he's like, "Oh, I don't know, Venus." There's something unusual like that. But now NOIRLab has created this amazingly cosmically cool thing, which everyone can go to, called the 88 Constellations Project. And I can't think of a better person than you, Rob, who may have, in fact, spearheaded this entire project to tell us about this cosmically cool thing, 88 Constellations.
Yes, well, it's a very interesting project to work on. I learned a lot. I learned a lot about working on it. But is the Eckhard? I'm not. I apologize. I'm probably going to mispronounce his name here. Eckhard Slavik.
Okay.
I'm not sure how to pronounce his name. Took these wonderful all sky images.
Okay.
Just stitched together with this camera. He traveled to various places around the world to be able to photograph all 88 constellations. Have this huge, wonderful, full sky image.
Oh, nice.
And that was sort of the basis of 88 constellations, having these very high resolution, really nice images of the entire sky, so we could actually make something called 88 constellations.
Yeah.
So then we want to sort of see what is in each of these constellations. So we did a little research on the history of the constellations, their naming. Of course, some were named from the ancient Greeks constellations. There's other ones that are much more modern. So it's very interesting, especially the southern hemisphere ones are much more modern. And we sort of put all that together, looked at them. Okay, what are the good things to look at in these constellations? Were there historic supernovae in this constellation? Are there great star clusters, type things that astronomers could be interested in looking at with their amateur astronomers with their size telescopes and binoculars? And try to bring all this stuff together in one place for people to actually have and use as a reference source.
That's awesome.
That's wonderful. Now, how high resolution is this? Is this like 1,000 by 1,000 frames, 10,000 by 10,000 frames?
Oh, it's a huge images. Of course, I'd have to look and see what the resolution is. I don't remember the technical details of the images off the back.
Okay,
off the top of my head, but you're talking probably down to a couple arc second or two per pixel by the time you get down to the drill into it.
Whoa, arc second or two per pixel across the entire sky. I'm being a little technical here, so those of you who aren't familiar with arc seconds and arc minutes, I'm just doing a quick calculation in my head. There are 41,253 steradians in the sky, so I'm guessing you've got like 40,000 by 20,000 or so in the sky to get like 360 by 180, something like that. Like, in other words, millions and millions and millions of pixels.
So arc seconds, for people who know this, there's 360 degrees in a circle. Each degree is divided into 60 arc minutes. Each arc minute is divided into 60 arc seconds.
Right.
So I always say, the rule of thumb: hold your pinky at arm's length, and that's about a degree in the sky.
So we're talking about a 1/3000th of that.
Yeah, 130. So imagine, divide your pinky into 60 pieces, and that's 1 arc minute. Take one of those 60 pieces and divide that into 60, and you got your arc second. So you're exactly right now at about the 3600th the width of your pinky.
Incredible.
And that's the detail these are.
Some people have bigger pinkies, but they tend to have longer arms, so it kind of evens out.
It's one of those happy coincidences of human anatomy that the outstretched arm is about this much.
Yeah, it's about that much. It's not exact, but it's close enough for just give you a rough idea what to look at.
Wow, that's just fantastic, and I really am glad that this has been produced by you guys. Thank you for doing this because, well, we love the constellations, but normally most of us only see a few stars at a time, and if we can really match that, right? Maybe the combination of the research and the photography and things like that can really combine together to produce a more beautiful understanding as a whole of the sky, whether you are a professional astronomer or whether you are just an amateur. There's no such thing as just an amateur,
Yeah,
of course,
yeah.
but
Yeah,
just really liking it.
The
Um,
amateur just means you don't get paid for it. Doesn't mean you aren't good necessarily.
that's true.
there you
That's true.
go.
That's
Yeah.
really the right way to do it. Some of the most important discoveries in the history of astronomy have been made by people who weren't paid for their astronomical work. Yeah, so they're amateurs, and yet they are true professionals in terms of what they can discover, right?
Yeah.
Um, Rob, what do you feel like you learned, like one professional thing that you learned as you were putting together 88 constellations that really excited you or it sticks with you right now after doing this incredible project?
Well, to me, this was actually something that I wish, it wasn't just me doing all the constellations. I sort of spearheaded the project, but there are several of us who researched different constellations, wrote each constellation. So you may know some different style writing in some of the constellations,
All
but
right.
which is fun. I think it's great that we had some different styles represented in there. But I think that one thing I loved is learning about the constellations I don't see so much, the southern
Oh, yeah.
constellations, because I've only
Right.
been south of the equator a couple times, and it's been great and wonderful. But of course, you go south of the equator, and all of a sudden you're like, "Whoa! There's these things. I'm lost in the sky."
Yeah.
Learning some of them, I'm more excited to go back to the southern hemisphere again, so I can see those constellations in a new light and observe some of the more objects I've learned about in those constellations as well. So to me, that was the most exciting thing. And to be honest, when we were doing this project, like I said there were 4 or 5 of us who were writing all the different ones. There were some times where people said, I want to do this constellation. No, I want to do this constellation. Multiple people were excited about doing constellations. They wanted to actually learn about that constellation.
Oh, that's great. Yeah, I've only been in the southern hemisphere for a couple of clear nights.
Wow.
In Argentina on my way to the Antarctic, just to
Oh,
brag a
that's
little
right.
bit.
Wow.
Yeah,
Um,
yeah. You got to flex that trip, right? That's amazing. You went down to Antarctica by way of Tierra del Fuego,
right,
right?
but the thing is, in the Antarctic, I went in December, so it was the midnight sun, so I didn't get
Yeah.
to see any
Oh,
constellations there. So I did
that's
in
right.
Argentina on the way down.
Oh, that's
Um,
great. Okay, so let me ask you, Alan, and
Mhm.
then I want Rob to sort of give us the actual figure. What do you think, Alan, is the best known southern constellation amongst us northern hemisphere folk?
I mean, probably the Southern Cross if you're looking for a whole
Aha! Okay,
constellation.
the Southern Cross. Rob, is that true?
But I don't have statistics to back it up, but I would say yes. That would have been my first instinct as well. Southern Cross.
Yeah,
It,
Crux.
yeah, the Southern Cross is interesting in all kinds of ways, right? First of all, it does in fact look like a kite. It
Yeah,
totally looks like a kite. There are 4 stars, but it's really small. It has a
Not
smallest
big.
area, right, of all the constellations, but it's so clearly visible.
is
And
Delphinius smaller?
I'm not sure.
Delphinus, the Delphinus, the dolphin.
It might be
Ah,
smaller
It's
than
pretty
Crux.
small. Yeah.
yeah, yeah, yeah.
They're both
I
pretty
don't have
small
the
though.
order memorized, but that is one of the
That's
smaller
right.
ones. Yes.
And in the 1980s, Crosby, Stills, and Nash had a song called "The Southern Cross," and I just remember it for no apparent reason. But when I was very young and I heard that song, there's one line of the lyric that I can remember, and it's just, "When you see the Southern Cross for the first time."
Yep.
And then I saw the Southern Cross for the first time some years later when I was in graduate school. And it's like, yeah, but I don't remember what I was supposed to feel because I haven't heard that song since way young. What are you supposed to hear about? What are you supposed to know about it?
Yeah, I don't know. So I was just looking up the list because I was curious now which one is smaller. So
Yeah.
Delphinus the dolphin is in fact number
The smallest?
69 out of 88. So it's
Okay.
not the single smallest. Crux
Oh, okay.
is smaller.
Crux is the absolute
Crux is
smallest.
the absolute
Okay.
smallest. It's just
All right.
barely smaller than Aquilius, which is right above it. So
Yeah.
Wow. Okay. All right. Okay. Let
My
me see if
first-
I can remember.
I'll
Go
just
ahead. Go ahead, Rob.
My first time seeing the Southern Cross when I graduated from college. My first job was teaching high school on the island of St. Croix in the Caribbean.
oh,
That's,
nice.
that is far enough south, plenty far south to see the Southern Cross, obviously. That's about
Uh-huh.
17.9 degrees north latitude. So see most of the southern sky. And this was,
Mhm.
of course, in 1990.
Uh-huh.
So,
Uh-huh.
and let's just say that the internet did not have readily available star charts for stuff south of the equator at the time. So
Oh, all right.
finding information about the southern constellation was much more difficult back then, especially when on a small island which has one bookstore which does not specialize in astronomy books, to say the least.
Eek.
Let's see if we remember this. When you see the Southern Cross for the first time, down, down, you understand why you came this way. Never mind. I just don't
Yeah,
remember.
well, we can't sing too much of it anyway because the copyright police will get
Oh
us.
yeah,
So.
yeah. Oh, sorry, copyright team. Yeah. If you need to cut out part of it, just go
We're in
ahead and do
trouble
that.
now.
I think that much is fair use. I think it's fine.
Okay.
And,
And what's cool,
and that rendition, I think, is also constitutes fair use. So.
Oh yeah.
because it's so unsimilar to the original, right? It's totally funny.
But also, you can see the Southern Cross from the Florida Keys. If you're familiar with the Winter Star Party, one of the big star parties down the Winter Keys on West Summerlin Key, hosted by the Southern Cross Astronomical Society. So named because the time they host it, late January, early February, the Southern Cross does skim the southern horizon. That last star does make it above the horizon.
Oh, that's great.
I lived in Bradenton, Florida for several years, and that's farther north, and you can only see the top three stars. And the bottom star would not hear the horizon from Bradenton, but from the Keys it does.
That's great.
So instead of the Southern Cross, it's the Southern Triangle, right?
Yeah.
Okay.
Yeah.
We also have songs about the Florida Keys, because off the Florida Keys, there's a place, presumably, where you can see the entire Southern Cross.
Yes.
Anyway.
Yeah.
All right. Well, let's take a brief break now, and then we'll come back with a question from the audience for Rob Sparks here on the LIUniverse. We'll be right back. Hey, we're back here on the LIUniverse with Rob Sparks from the NOIRLab, the National Science Foundation's Optical Infrared Center. This is cool. Okay, it's time for a question from the audience. Alan, do we have one for Rob?
Yeah, this one comes from Amira, and Amira is asking, blue stars are hotter than red stars. So does that mean blue light bulbs are hotter than red light bulbs? Why would something's color matter about how hot something is?
Great question.
That is a great question, and not sure how technical I should go here. I'll try and keep it to without too much jargon here. So I'm going to confine myself first to the temperature, the colors due to temperature. Okay. All objects give off this stuff called black body radiation, basically because they have temperature. They're above absolute zero. And for humans, we're about 98.6 Fahrenheit, 38 degrees Celsius ballpark, somewhere in there.
Yeah.
We give off in the infrared. We glow in the infrared. Now, as you keep getting things that are hotter and hotter, eventually they give off visible light and eventually even ultraviolet X-rays and gamma rays for really hot stuff. So you keep making it hotter and hotter. So yeah, red light is longer wavelength, has less energy than blue light. So hotter things give off blue light, cooler things give off red light. And that's definitely true. So, and that's generally true for stars. I say generally stars, some stars, like one of my favorite types of stars called the carbon star.
Oh, okay.
They're these highly evolved stars, which being they're very close to the end of life, they're red giants, but they have carbon at their core and they start pulsating, and this carbon gets dredged up to the surface. Now, carbon is very efficient at absorbing blue light. So these are some of the reddest stars you'll ever see. So they're red, they're cool because they're red giants, but it's even redder because the carbon absorbs light too. So most of the color is due to temperature. There can be other circumstances like carbon stars where gases and things can alter the color of stars as well.
Okay.
Yes. And now I think about light bulbs, for instance. In the old incandescent bulbs, you'd have to make a hotter bulb to get different temperature, that sort of thing. But LED bulbs, light emitting diodes are what we call, have these junctions in them where you have electrons in one energy level, electrons in a different energy level. And electrons drop from this energy level to this one and give off light. If the energy level is a big gap, that's more energy, they give off blue light. Smaller gaps give off red light. So LED bulbs are not different colors due to their temperatures, they're due to those different energy levels in the semiconductors and how far the electrons have to drop from energy level to the next. So there's different types of lights that give off, they're not always temperature dependent. But gases and stars, they're pretty temperature dependent.
So if you're just glowing because you're hot, then a bluer thing is going to be a hotter thing than a redder thing. But if there's chemistry or electronics involved, then you might not necessarily have that same correlation.
That makes total sense. Wow. So the way you've described it, really, an LED light bulb, which is in most of our homes today in the United States, right?
And your cell phones, flashlight, and everything.
They're basically not glowing because of their heat, but because of their quantum energy structures, basically?
Yes, Wow. Going to get really technical, they're called p-n junctions, where you have a p-type semiconductor, n-type semiconductor, which have different energy levels. You have electrons falling from here into the gaps in the n semiconductor, and again, that gap determines the color.
Wow.
It's pretty
Well, you
awesome
heard,
stuff.
yeah, you heard it here, folks. Your house is being lit as we speak by quantum devices.
Yeah.
Hope I
Yeah.
remembered my solid state physics well.
I'm sure you did. You have both undergraduate and graduate degrees in physics. And like you said, you worked at Fermi Lab, which is one of the great particle physics laboratories in the world in Illinois for a bunch of years. So you've got quite the pedigree there. What brought you into what you're doing now today? And not to mention what brought you to Florida and Thomas, St. Croix. Yeah, these amazing places. That's physics, astronomy. What?
Yes. Yeah, well, like I said, I've always been, even since I was a little kid, I was always into sharing my interest in astronomy with everyone else. And I was
That's the
thinking about
best.
it recently, and the first time I can remember actually sharing astronomy and trying to educate my fellow classmates, so to speak, about it was the 1979 total solar eclipse.
Ooh.
My parents didn't take me out of school to go see totality, even though we were in Northwest Iowa, and one day car ride would have gotten us to totality. But I brought my trip in and showed a 90-some% eclipse to everyone else, and I've sort of always been in that astronomy education outreach time thing ever since. Bringing
That's awesome.
scopes to schools and having
Cool.
friends over with the telescope as a kid and that sort of thing. And
Wow.
I always wanted to study astronomy, so I did physics in college, and also did TA and all that stuff in college, and worked the observatory showing people stuff on public nights and everything. So
Neat.
That's always the
growing
best.
and growing with education and astronomy. And so when I decided to take a year off between undergrad and grad school, I applied for a teaching job and got that job on St. Croix teaching high school.
Wow.
That's great.
So that's a great way to spend a year off between undergrad and grad school. And in grad school, I was still doing, obviously, I did particle physics in grad school instead of astronomy, if you can believe that. So I was more in particle physics then, but still interested in astronomy. But for those who say that's a weird choice, a lot of particle physics problems are astronomy problems. Cosmic ray showers, particle showers, the solar neutrino problem, neutrino oscillations. There's all kinds of astronomy and particle physics really intersect in a lot of ways. And Michigan State had a stronger particle physics program at the time than astronomy, so it kind of made a little bit of sense to go for that.
I love that neutrino oscillation problem. It's like there's 3 different flavors of the particles, and they call them flavors, and that they change from one to another on the way here from the sun. And somehow that totally messed with our first generation of detectors.
That's true. We were only detecting 1/3 the number we should have, but that's because I believe the electron neutrinos we were supposed to detect were also changing into tau and muon neutrinos on the way. So hence their 3 flavors, we were detecting about 1/3 of what we should have. I have a piece of the scintillator material from the near detector for their neutrino experiments at Fermi Lab. They were building them when I was there.
Oh, wow.
You stole a piece of scintillator material from Fermi Lab?
But they gave us a tour of the facility, and there was a bucket of them. They said, if you want a piece of scintillator, take a scintillator. So I took a scintillator.
Okay, relieved that you came about this legally as opposed to illegally. Scintillator material, huh? That sounds kind of exciting. Scintillating even.
Hey.
Sorry, you saw what I did with that.
See
What is scintillator material, Rob?
Oh, there's a variety of scintillating materials, but basically when a particle interacts with them, it causes a little spark of light, a little flash of light to be emitted, so you can actually detect that there was some particle there. And of course, in a particle shower, you might get multiple flashes of light, depending on what types of particles there are. So they detect everything from your subatomic particles. There's particles called muons, and neutrinos, and that sort of thing can all be detected with various scintillator material.
Fantastic. Okay, we're going to talk much more about this scintillator material in a Patreon extra that we're going to record right after this episode. Okay, so those of you who are interested, find this illuminating, please join us on Patreon after this, and we'll get a chance to see all the cool stuff that we talk about this particular topic. Let's take another question. Alan, another question from the audience, please.
Yeah, sure. I'll take this one because it seems relevant to the conversation we've just been having. This one is from Brian, and he asks, how does astronomy and physics work together?
Brian, boy, that's a philosophical tangent, philosophical deep dive right there. But I'll at least tell you a few ways that can work together. one of the big assumptions, of course, that we have to make is that the laws of physics on Earth are the same of laws of physics elsewhere. So that's
Okay.
one big assumption we have to make sure that everything works here. But of course, astronomy is until recently primarily an observational science. We can't go to stars, we can't go to other galaxies. We have to just observe them. But of course, we can observe things on Earth and compare to how they behave in those other stars. So if we look at a gas, the tube of hydrogen gas, we can look at spectrum and see it gives off certain wavelengths of lines. And we see those certain wavelengths of lines coming from other stars or objects in the sky. We can assume those lines are due to hydrogen. Helium has a different pattern of lines, and iron and nickel and all the different elements have different patterns of lines. So we can deduce what gases are present in other places based on studying physics and chemistry of those elements on Earth. Just like we do experiments with redshift on Earth. We actually do experiments with light sources coming toward us or away from us and observing the redshift. We see other galaxies observe those redshifts. We can deduce they're moving toward us or away from us and calculate speeds based on these redshifts. And some things like we can only take snapshots of things in the night sky. We can't see galaxies moving and colliding and that sort of thing. So if we see two
millions
galaxies,
or billions of years,
yeah, so over billions of years. Galaxy collisions are a great example. They can take millions or billions of years to play out. So we see two galaxies interacting with each other, gravity pulling stars from one to another. We can only see where they are right now. But of course, we can look at the light, we can measure where the stars are in the mass distribution of those galaxies, and then run the simulation forward and see what the galaxy will look like in the future, or what they may have looked like in the past by just putting that information into a simulation in the computer, running it through the physics and seeing what happened. So there's a lot of ways physics and astronomy interact.
Right. Those computer simulations are literally running things like Newton's law of motion, right? The laws of motion that Isaac Newton developed hundreds of years ago that form the foundation of a lot of physics today and everything. So that's tremendous that it's right. So in a sense, would you say, Rob, that it is the study of physics here on Earth that has allowed us to understand the workings of the universe?
We definitely wouldn't understand the workings of the universe out there if we didn't understand them here. So definitely, yes.
Yeah.
All of you who are worried about like physics and like intimidated by it, don't be. Physics is awesome. Physics
It's a
is
lot of
fun.
fun.
Yeah. And physics helps the cat that just walked across the back of your room. I love that. Yeah.
My partner closed the door so there wouldn't be any noise here. Now the cat wants out of the door.
That's hilarious.
That's great.
For those of you who are not on the video and are just listening to this, beautiful black cat just kind of walked behind you. But unlike the Chicago Cubs, who had the black cat walk in front of their dugout and thus caused them to lose the 1969 pennant to New York Mets, this was behind. So this is a good luck, Marshall, right?
Well, if you watched the Tampa Bay Buccaneers football game yesterday, they had a duck on the field.
It
was during a punt return, and the punt got blocked, and there's speculation that the team may have been distracted by the duck and allowed the Bucks to block a punt accidentally. So,
my goodness!
All right.
Yeah. Well, since the Buccaneers are probably very happy with that. I mean, they are pirates after all, right? So the ducks are good luck charm or
Buccaneers.
The Buccaneers.
All right. Yeah, one of the things from that physics conversation we were just having about reminded me, you're talking about the spectral lines of different elements and how they give off these different wavelengths of light from their electron levels, like we were talking with LEDs.
Yeah.
Helium, the element, is named helium because it was discovered in the sun before it was discovered on Earth. So most of these elements, we see them as a gas on the Earth. We see what their spectral lines are, and we look somewhere else in the universe and say, oh, this element must be there. But for helium, it was the opposite. They saw this in the sun, and like, well, these extra spectral lines must come from some element, probably. And then they found the same gas on Earth, and they realized it was the same thing they found on the sun.
Wow.
Hence the name helium from Helios, i.e. sun.
Yeah, It's pretty awesome. I love that story.
Yeah. So our study of the universe also helped us understand our own Earth. That happens time and time again, right? So
of course.
That's really quite exciting. Okay. So, Rob, I understand you do lots of theater.
Yes.
And comedy and acting and things like that. We have to get astronomers and astronomer educators who act and sing and dance and jump around and show us stuff. So a little bit of airtime here. So you got to tell us about that. Tell us about that part of your coolness as an astronomy educator.
Yes. Well, I've been acting, since I was a kid. So back in high school, grade school plays, and when I got to college, that's when I joined my first improv theater troupe. So that's I'm pushing my 38 years of doing improv.
Dang.
That. And I joined the improv troupe and been doing it ever since. Improv theater, of course, means spontaneous creation, usually from audience suggestions. Most people are familiar with the TV show Whose Line Is It Anyway, which they do short scenes based on suggestions.
Drew Carey used to host that,
yes,
right?
Drew Carey hosts that. I actually passed him in a half marathon one time. He's a runner.
That's amazing.
So you run faster than he does.
Well,
okay.
He was a celebrity, so he got to start at the front. I had to start at the back of the pack, but I caught him and passed him during the race. So
nice. I love that. Alan, there's some sort of online versions of that show now, right? Not on network television, but you can find it.
Oh yeah. Like Dropout, of course, has theirs, and like
they have a lot of great stuff
YouTube
there. Yeah.
things all over the place. Yeah.
All right. So we should do. Okay. Let's do an improv thing for you right now.
Really?
All right?
This is
yeah.
exciting.
Are you ready? Okay.
Go for it.
Rob, are you ready? Okay.
Sure.
Okay. Let me think of it right now so that. Okay, I got it. You are an astronomer trying to observe something, and as you're trying to observe it, Drew Carey runs by. Imagine the conversation between Drew Carey and you. Can you do that conversation?
Can I do two characters at once is what you're asking?
Yeah. Give it that shot. I mean, nothing against Drew Carey. This is a positive thing. Mr. Carey, if you're listening, this is totally as a tribute to you. Okay. We're doing a Whose Line Is It Anyway version of an astronomer being passed by Drew Carey in a half marathon. Okay, Rob.
Actually, in a half marathon, even. Okay. So.
Even a half marathon. Yeah, let's give it a little extra color here.
I'm gonna do the best recreation I can of the event, which will be mostly monologue.
Okay. Cool. Go for it. Yeah.
Okay. 5 miles in, about 5 miles. Oh wait, that guy in the yellow shirt up there. Wait, is that? Could it be? They showed him on the jumbotron at the beginning, and he was wearing a yellow shirt. That could be him, right? Oh, I'm going to catch him. Here he comes. Oh, that's him. I'm going to be cool. Okay. Yeah, I was cool, man. I was cool.
Those of you in the audience who are just listening on the audio, Rob just gave a little salute, a little hello, a little off to the side.
That was amazing. LIUniverse first improv acting that's not just us answering questions,
That's marvelous.
The Improv Olympic it was Improv Olympic. It was known at the time as a big improv club in Chicago.
Okay.
They actually have a program for scientists to learn how to do improv. And
nice.
They've done workshops at CERN, the particle accelerator in Switzerland, teaching people how to do improv and teaching scientists to be better science communicators.
That's awesome.
And you might be familiar with the Allen Alda Center for Communicating Science to the Public, I believe is the proper name of the organization.
Right. Yeah.
And they gave a workshop here in Tucson several years ago, and I got to go to it on communicating science to the public. And they really focus on improv skills while doing the workshop. And it was kind of fun because the facilitators of the workshop actually were also alumni of the IO in Chicago, as am I. They were there before I was, but we were able to talk about, we were able to actually reminisce about some of the people we knew from IO who overlapped us.
That's so cool.
Yeah.
Some of the other people who were instructors there that we both had in common. So that's kind of fun.
Amazing. Yeah, there are members of our own production team here on the LIUniverse who came out of Second City, the famous improv location, the comedy place in Chicago. So this is all very good. Folks, if you want to see exactly what Rob just did, even though you're listening, subscribe to our YouTube. You get a chance to see some of the cool video stuff, like including the cat that walked by.
Yeah.
The cat really wants out the door that is closed.
Yeah. Check out the LIUniverse channel on YouTube. And just for this one last thing, we got to make sure. Okay, Rob, we have to have you do a visual improv. Okay, the cat is walking by again. Okay.
Yes.
You play a cat feeding YouTuber who suddenly needs to feed that cat, but that cat is halfway behind your chair and is refusing to come out. Do a visual 10-second thing of what you try to do. Oh, there goes the cat. Okay, go, Rob, go.
Okay. So come on out from the chair. Okay, you're halfway out. Now you're 3/4 the way out. Now you're 7/8 of the way out. Now you're 15/16 of the way out. This is Zeno's cat right here. Will never come out from behind the chair.
Amazing.
It's
Love
true.
it
It's
as
gone now.
the resident math person. I love that.
Uh-huh. Oh, that's marvelous. All right. Well, let's do one more.
No,
We could
Dad.
talk all day. What?
We have to do some other things besides just this.
No.
I love
All right,
this
okay.
one, but we have other
All
things
right.
to do too.
All right. We'll just have to save it for the next time you come back, okay? Because we just need that improv. It's too much fun. Okay, let's do one more audience question.
Okay.
All right, let's get one more audience question for Rob. Okay, go ahead.
All right, cool. Oh, cat is moving around.
Now,
again.
cat showed up.
Just when you least
Is
expect
the
it.
cat there or not there? This is Sparks' cat, not
Yeah.
Schrodinger's cat,
A
right?
little bit nicer.
Her
Nicer
name
for
is
the cat.
Anime, just so you know. Anime is in the Japanese animation style.
Oh, that's awesome.
Okay, let's get one more question in for Rob Sparks on our episode. Alan, pick a good one.
All right, I'm going to pick this one from Jerry, who is asking, I live really far away from the city and I don't have a telescope. What's the best way for me to do astronomy research?
Oh,
That's
great
an
question.
interesting
Yes, Rob, didn't you just say that you were like from northern Iowa or something like that? Or
That's where I
or-
grew up, yes.
yeah, so you might actually have some real good insight to this particular question.
Yes. Well, I don't know how old Jerry is, but there's a variety of ways they can get involved doing astronomy research. There's a variety of online projects with the LIUniverse, which do citizen science.
Aha.
And they actually have a variety of projects. You can go on and log on and choose the one that interests you. And they teach you how to do astronomy research to contribute data to their astronomy research. The original project was called Galaxy Zoo, which involved classifying galaxies, but there's many new ones now where you're looking for extrasolar planets around other stars, where you're studying solar flares and that sort of thing. And of course, it's not just astronomy, there's dozens of other ones as well.
Okay.
And the American...
Let's assume Jerry is a full-grown adult.
Okay.
And is well versed in things and is curious and is skilled in stuff. Is the Zooniverse or is the things you're talking about still relevant, still valid?
I would say definitely yes, because the Zooniverse, if you can just I'll take the original Galaxy Zoo. Original Galaxy Zoo was just start out as classifying galaxies, but they have forums where people can actually explore different things in the data. And one thing that was well known at that time, they kept discovering these little green dots in the images they called them green peas. So after about 5 pages of people making puns about peas, they started getting serious about it, and people who were interested started writing algorithms that would search the data for these things and actually look for them and pull them out. And then when they had a whole collection of them, they went to the professional astronomers and said, hey, we found these weird objects which we don't know what they are. Have you ever seen these before? And the special astronomer said, no, that's interesting. So the special astronomers started researching these green pea galaxies, these little green pea dwarf galaxies. So they literally discovered a new type of galaxy from that data. So you can either just do this project, or you can really dive into it and get your hands dirty with some real research and possibly make some real discoveries. Another famous one from Galaxy Zoo is Hanny van Arkel, a Dutch school teacher, discovered this weird halo around something, which is now called Hanny's Voorwerp. It's named after her.
Oh, that's awesome.
And there was one of the galaxies said, hey, what's this weird thing? And she'd point out people, and they start doing research on it, and it was something never been seen before, this light echo. From, I believe, the quasar light echo, if I remember correctly. Quasar, of course, the quasar is a bright galaxy eating a black hole eating a bunch of stuff in a galaxy. It gives off light, but the black hole stopped eating stuff, and there's this cloud of gas out here that the light reached much later. As we see this arc, this reflection of light given off by the quasar, which is no longer shining, that's now traveling toward us. And they've discovered other of these type of objects too since then. But and my favorite part about that is Galaxy Zoo, they actually showed the same galaxy to multiple people to classify it. And Hanny van Arkel, she was not the first person to look at that image. She was the 27th person to look at that image.
Wow.
She was the first person to say, hey, what's this? So she gets credit for the discovery.
That's awesome.
Wow.
Was so cool. That could have seen before her.
Gee, was Hanny van Arkel a scientist, like a trained
school teacher?
A teacher,
school teacher in the Netherlands. Yes,
that's awesome.
Not a trained scientist, but a school teacher in the Netherlands, and they actually did a comic book about her too and her discovery. So
whoa,
that's great.
I think I have a LIUniverse published. I think I have a copy of it around here somewhere. I have to dig it out, but
wow.
Yeah, well, we at the LIUniverse definitely appreciate the name pun of the Zooniverse as well.
So that's great. This is great advice for people. Anyone who wants to do something and maybe get yourself profiled in a comic book, check out the Zooniverse
And I will also
online.
just say that as the Rubin Observatory comes online, they're planning citizen science projects as well. So look for those as the Rubin Observatory starts collecting data.
That'll be
Wonderful.
awesome.
Can't wait. Absolutely. Oh, my goodness. The time has flown. I wish we had more time, but we will do this again. Okay, Rob? We'll
Oh,
find some
definitely.
time
I'd
to
love
chat
to.
more about this great stuff. So, Rob Sparks of the NOIRLab of the National Science Foundation, thank you so much for being with us today. Thank you so
Oh,
much.
you're welcome. It's been a pleasure, Charles.
Allen Liu, our co host, thank you for everything that you do on being on this episode, too. Thank you so much.
Yeah, you're welcome.
And for all of you in the audience, thank you for being with us on this episode of the universe. If you like what you've seen and hear, please support us on Patreon. And as always, thank you for being a part of the universe.